This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for another Satellite Book Club. This is session number 53 of the seminar series. Got a presentation from Jorel Torres, Research Associate and JPSS Satellite Liaison at CIRA, JPSS Fire Monitoring Capabilities for NWS Users. So fire weather season just getting started out west. Facilitator today is Chauncey Schultz, Science Operations Officer at the Weather Forecast Office in Bismarck. Just a few reminders before I turn it over to Jorel. This session is being recorded, so you can find the recording afterwards for your colleagues that are unable to join us today. We will have some Q&A after the presentation, so please feel free to post your questions in the chat and we will field them in the order they are asked. Always looking for future presenters. If you have an application you'd like to share with your colleagues, please get in touch with us. We'd love to have you. And if you're looking for training or need help creating training materials, Brian Mata, in the Office of the Chief Learning Officer, and his team of scientists at the Cooperative Institutes can help you with that. Just thanks to the Tower S team, particularly Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, GOZAR, and the JPSS program for all supporting the Tower S team and all the great work that goes on behind the scenes. After Jorel's presentation, Chauncey Schultz will take over with the Q&A. Jorel, liaisons between the National Weather Service user community and the research community, focusing on JPSS products, applications, and satellite training development for users. In his spare time, Jorel loves to storm chase, travel, hike, and CrossFit. So Jorel, welcome back to the Satellite Book Club.
Well, thank you, Jordan, and thank you for that introduction. And it's nice to be back. I remember last year where I was like the second or third person to present at this SBC seminar series when it first was incepted. And but it's good to be back. And once again, thank you, Jordan. And as Jordan mentioned, my name is Jorel Torres, and we'll be speaking on these fire monitoring capabilities for National Weather Service users. And so let's get right into it. So first of all, just as a refresher and as a reminder for users that are not familiar with JPSS, here's just a quick little review of the Joint Polar Satellite System. You know, you have the two satellites, the SUMI National Polar Orbiting Partnership, or SNPP. Then you also have the NOAA-20 satellite, or also known as JPSS-1. These satellites have identical instrumentation on board. They comprise of 5 instruments on board each of those satellites, but we'll only focus on 3 here. The VIIRS instrument that has 22 spectral bands at high spatial resolution. And then, of course, you have the ATMS and CRIS instruments or sounders that provide your temperature and moisture profiles that can be implemented into blended products and then also integrated into the NWP model datasets as well. Now, with the polar orbiters, they provide global coverage over the oceans and remote areas where radar coverage or ground observations are poor or limited. They also provide observational value in complement to the GO16 and GO17 datasets as well. Now, some of the limitations that users should be cognizant of are the coarse temporal resolution, along with the data latencies or the time of the satellite overpass to when that dataset is in your AWIPS system. So if users have access to the SBN datasets or the satellite broadcast network, the data latency is about an hour to an hour and a half. Now, in regards to the temporal resolution for CONUS users, it's approximately 2 overpasses a day for polar orbiting satellites. But of course, if you're an Alaska user on this telecon, you're going to get more frequent overpasses near the poles. But then also something to also consider are the direct broadcast capabilities, and users that have access to that, you'll have access to the lower latency products, which could be on the order of around 30 minutes or so, depending on the channel and or product. But with the JPSS program, we also look forward to more datasets in the future for users, and we're looking forward to the JPSS-2 launch, which I believe is scheduled in the fall of 2022. At the moment, tentatively scheduled for then. And from that, now how this relates to the 2021 fire season, of course, it has already started, but here I'm just trying to connect the JPSS fire applications to this fire weather season. And just wanted to highlight to users, this presentation will highlight how users can employ your JPSS datasets, channels, products, RGBs with respect to fire monitoring. Some of that will consist of how you can observe, say, like fire hotspots, fire intensities, fire smoke, some of the burn scars that you can observe from the high spatial resolution datasets as well, that you can utilize for hydrological applications and flash flooding. Also, how users can be able to employ your satellite-derived soundings, along with, very importantly, how users can access near real-time datasets in AWIPS, but then also critically online as well. If a user is, say, deployed, or an IMET that is deployed to a fire, and say that the products are not available in their thin client, or they just only have access to online websites, I have a lot of links that could be useful for you. And note that this presentation will be, and the examples are going to be predominantly CONUS-centric. However, I did not forget about our Alaska users as well, and I'll have some documentation for CONUS users and then also Alaska users that I'll highlight near the end of this presentation. So we'll get right into some of these products, channels, and/or RGBs. First ones I wanted to highlight here are your VIIRS Fire RGBs. These are currently available via the CIRA LDM in AWIPS. If you have interest in these RGBs, you can connect with me or Curtis Seaman from CIRA, or Bill Line from NOAA NESDIS as well. But these VIIRS Fire RGBs can detect these active fires at high spatial resolution. What you're seeing here are the two RGBs of interest. You have the VIIRS Dayland Cloud Fire RGB on the top there, that you can not only observe the active fire, but this RGB, since it employs the vegetation channel within its RGB spectra, it is sensitive to fire smoke, but then also, very importantly, with the vegetation channel, it is sensitive to vegetation health in regards to burn scars as well. And what you're seeing there is the fire smoke that is being emitted from the Three Rivers fire in New Mexico back in April of this year. And this is how the imagery looks in your AWIPS system if you have it. In addition to that, you also have the VIIRS Fire Temperature RGB, which can be employed in a qualitative manner to infer your fire intensities. And if I zoom in onto that fire there in the bottom image there, you have pixels that transition from red to orange to yellow to white pixels. Red pixels indicating your cooler fires, and where your yellow and white pixels indicate the most intense fires. And so you can see or infer in this imagery of the Three Rivers fire that the most intense portions of the fire appear to be within the center of the fire there. And also note with the VIIRS Fire Temperature RGB, it can be employed for the nighttime fire use as well. And I'll show an example here in a second. This next animation here just shows, or this next two images show how these RGBs are seen online. This is actually via the Real Earth interface, and it's observing the Cameron Peak wildfire last year in late 2020 in north central Colorado. But this is just how the RGBs look via online. And in addition to that, as I was mentioning earlier, the VIIRS Fire Temperature RGB, if you look at this bottom image here by my cursor, it can be employed for nighttime fire use. This is just a nighttime fire case from some fires out there in California. And now the top image here is an AWIPS image just within the last few days, as I was able to capture some of the recent burn scars that still exist right now from the Cameron Peak fire last year, the Mullen fire that straddled the Wyoming-Colorado border, along with the East Troublesome fire burn scar as well. In addition to the VIIRS Fire RGBs, we also have the VIIRS Active Fire product as well that you can utilize day or night. It is at high spatial resolution, and it has three main data outputs. You can observe your fire location. It also has the fire radiative power, or the fire intensity, which is expressed in megawatts. And then you also have your fire detection confidence from 0 to 100%, where the percentage just means it's the percentage that a fire exists within a pixel. This product is available in AWIPS via LDM. And here's just a few examples in AWIPS of how it looks and how it's overlaid onto some other products here. You have the VIIRS Active Fire here overlaid onto the VIIRS Dayland Cloud Fire RGB, observing some fires out there in southeastern Arizona. When you sample the data sets, you'll get your timestamp, the satellite it comes from, your fire detection confidence, along with your megawatts there. And note as well here in the bottom, just the range of your fire rated power values, where yellow circles indicate the lower end of the spectrum on fire intensity, but then as your circles go from yellow to orange, orange to red, and to dark red, it gets more and more intense. And the darker reds indicate fires that are 2,500 megawatts or higher there. So this is just an example here of the VIIRS active fire. Here's also the VIIRS active fire overlaid onto your GOES data sets as well. This is just like over the GOES visible over a small fire out there in, I believe, the Florida Panhandle. And you could also see some of the fire smoke that's being observed from the GOES 16. And then also some of the smaller scale fires out there in, I believe, northwestern Arkansas. And note of some of the links I provided here for users online as well. In addition to that, you also have your VIIRS near constant contrast product, or NCC, along with your shortwave IR, your 3.7 micron. Predominantly focus on the nighttime visible imagery, or your NCC. As a reminder, your NCC is a derived product of the day-night band, which utilizes the sun-moon reflectance model to help illuminate your features during the nighttime, whether it be atmospheric features like clouds, but then also senses emitted lights as well during the nighttime. So for fire applications here, you can observe your emitted lights from the fires, but then also you can also observe smoke at night as well, which is also key for your impacted areas. And here's just an example of being able to observe your emitted lights from fires. This is an example from the Pine Gulch fire, which was just located just north of the city of Grand Junction along the western slope in Colorado. As you can see, the emitted lights from that Pine Gulch fire. But the question becomes, when you're utilizing this nighttime visible imagery, you see the array of emitted lights, but how can you have more confidence that these emitted lights are coming from the fire and not from, say, nearby cities and or towns? And here's just an example of another fire case out there late last year in Oregon. And what you're seeing here is an overlay between your nighttime visible imagery, where you see you're an array of emitted lights, but then you have it overlaid with your high resolution 3.7 micron channel, observing pretty much the fire perimeters of these fires and those hotspots in black pixels there, especially along east of the Interstate 5 area. You'll see around my cursor those fires that are there, and you can correspond those fires with the emitted lights observed in the NCC. And now conversely, you'll see emitted lights along the Interstate 5, along my cursor here, and all the way up to Portland. And you can see that those emitted lights don't have a corresponding thermal signature or black pixels associated with them. So you can infer that those areas are emitted lights from cities and or towns, or pretty much non-related to the fires. But these are just some capabilities that you can utilize for fire applications. Also, of course, it's available in AWIPS and also online. Here's some links for imagery that you can go check out online as well. In addition to this, we also have the HERS smoke model at 3 kilometer horizontal grid spacing. With the model, it's initialized by VIIRS and MODIS FRP. Here's just an example of utilizing the near surface smoke and also the vertically integrated smoke products, observations of the Pine Gulch fire in western Colorado, along with initializations of other fires out there in California, along with in Idaho and other areas in the western CONUS. But you can see how you can utilize these products to simulate your fire, that simulate your fire emissions, plume rise, and also smoke distribution as well. And I know this has been a fan favorite for WFOs, especially for messaging via the social media platforms as well, to message what areas will be impacted with smoke. And in addition to these products, there's also the availability of the vertical cross-section capabilities as well. Here's an example of the Cameron Peak wildfire along with the East Troublesome wildfire emitting their smoke and simulated into the model here, and how you can observe your smoke concentrations related with height, especially over high terrain or high complex terrain there. You can see how it gets pretty high into the atmosphere there, and you can utilize that as well. In addition to that, we also have our satellite-derived soundings capabilities that you can utilize in concerts with your RAOB observations, or where RAOB observations are poor or limited. So essentially, a lot of parts of the Western CONUS. And with these NUCAPS soundings, or the NOAA Unique Combined Atmospheric Processing System, you have these temperature and moisture retrievals that are observed in AWIPS, just an array of dots in green, yellow, and red dots. And those different dots indicate the quality of the sounding. The green dots essentially mean it's a good quality sounding. And then also you have the gridded NUCAPS capabilities, where you can observe your temperature or moisture retrievals in a plan view or even in cross-section displays. But I'm showing just the plan view here, just as an informative here for the users here. It's gridded NUCAPS plan view of the TPW observations over Western Colorado and near the Pine Gulch fire, or near the star here location. And then I also have picked out a nearby NUCAPS sounding along with a RAOB observation and how you can utilize it. And here's just a comparison between your RAOB and your NUCAPS sounding. But note, on this particular day, the NUCAPS sounding is about 4 hours ahead of the RAOB. So just know that. But you can utilize the NUCAPS in between your RAOB observations of 0 and 12Z. And here you see that the NUCAPS sounding has a good general idea of the atmospheric environment. Sure, it doesn't have as fine of a vertical resolution as the RAOB observation, nor does it provide wind measurements as the RAOB does. But it's nice to be able to utilize it here to observe that dry boundary layer that's being observed all the way up to about 500 millibar. And how that is, how dry that boundary layer is one of the several parameters that could be conducive for more fire spread or fire initiation. And then here's just additional links here that you can go online to go check out NUCAPS, the NUCAPS datasets online. And I also wanted to mention as well just some of the differences, specifically highlighting the differences between your shortwave IR from your GOES ABI, specifically the 3.9, compared to your VIIRS 3.7 micron. As you'll, of course, utilize this in fire monitoring, whether it's just be the individual channels here, or if you utilize the RGBs that employ these respective shortwave IR channels, but how the GOES ABI 3.9 compares to your VIIRS components. And here's just an example of a fire a few years back in Washington State, around 1950Z timestamp, where there's a fire located within the white ellipse. And this comparison is just to show the pros and cons of both satellites. So with the GOES, for example, of course, it has that finer temporal resolution. You know, you have your mesosector coming in at 1 minute data sets. You have your CONUS sector at 5 minute data sets. But then, of course, with the VIIRS is not as timely. You only get it approximately twice a day per polar orbiting satellite if you're in the CONUS regions. But however, the GOES 17 doesn't capture the fine details of the fire, since the GOES 17 is at approximately 2 kilometers, assuming you're at the satellite subpoints. But with the VIIRS data sets, you're at 375, so you had even a higher spatial resolution. You can see the details, fine details of that fire perimeter, along with actually the river just to the west there, observing the differences in the colder brightness temperatures there as well. But point being, the whole point of this is also to highlight how you can utilize both data sets for fire monitoring, and just also be cognizant of the pros and the comparisons, and also the differences between the two. And also some other characteristics to consider when comparing these infrared channels, or like the AWIPS data latencies. Of course, with GOES, it's very minimal. I believe it's about 1 minute to 1.5 minutes data latency for the CONUS or the mesosector data sets. So really not much of a data latency at all compared to your VIIRS data sets, which could be on the order of an hour to an hour and a half if you have the SBN data sets. But of course, if you have direct broadcast access, your latency will be significantly lower to about 30 minutes or so. And then also something else to think about is your maximum saturation temperatures that lead to fold over within your spectral channel, so your 3.9 or your 3.7, or when those respective channels are integrated into the RGBs. So it is my understanding with the VIIRS, maximum saturation temperature is actually lower. It's a lower maximum saturation temperature compared to your GOES. So what you'll see in your imagery, whether it be your spectral channel or your RGB, you'll see that your VIIRS datasets will saturate quicker if it's a very intense fire compared to your GOES datasets. So just some things to think about. And as I getting close to a close here, I just wanted to highlight some additional resources for users that we have. I've been working with the JPSS Fire and Smoke Initiative the past few months, and thanks to all of those members and providing their inputs, we have developed 2 white paper documentations. One that highlights satellite fire detection and smoke capabilities for CONUS users, the other satellite fire detection and smoke capabilities for Alaska users. The content within these 2-page documents highlight the latest product RGB updates and operational status, the data access in AWIPS and screenshots of where you can access these products in your AWIPS system. And then also very importantly, we highlight a lot of publicly available resources online, especially that could be useful for users if they don't have the product in their AWIPS system, or if they're a deployed meteorologist or IMET that needs access to these data sets, but they don't have it in their AWIPS system, or their thin client is not working, or other reasons. We have these links for that users can access that near real-time data sets. And then also we also add some training links as well, just as a reminder for users if they're not familiar with the product, or they just want to re-familiarize themselves with the products, they can go check out those product links, training links. And you can access these documents via the Google Drive link there. You can also send me an email. I can give you access to that as well. Here is the, and I believe Kashad just put it in the chat there so you can access it. But here's just the screenshot of the CONUS user documentation here, and then also your Alaska user documentation as well. And then also shout out to Sheldon Cusselson, who's also working here at CIRA, and actually produced me some of the blended product imagery that could be useful for users as well in assessing the fire risk potential with the moisture products, whether it be the CIRA ALPW product, where the precipitable water is demarcated into 4 different layers that you can observe some of the drier areas, especially over the western CONUS. Then also your blended TPW, along with your percent of normal TPW products, observing the last few days of how anomalously dry it has been, and also some of the fires that we've seen in the western CONUS already, specifically out there in Arizona, and then also in Utah as well. And thanks again to Sheldon for providing that imagery. And then as I close, there's my summary slide there that you can read, and I leave you with some snapshots of WFOs employing JPSS data sets via their social media outlets and messaging, whether it be the HERS smoke and showing the potential air quality impacts and visibility impacts from the HERS smoke, and then also your nighttime visible imagery from a WFO out there in Oregon as well. And then there's my contact info at the top right there, and then there's just a graphic there at the bottom right, just showing my interactions between the NWS user community and research community, and how we want to enhance our R2O and O2R operations. And with that, I appreciate your time and letting me speak today. And if you have any questions, please ask away or type them in the chat. Thank you.
Thank you so much, Jorel. That was an excellent presentation, very timely as well, as I know fire weather season is about to kick off. So as Jorel said, I'd encourage you everyone to stick around. We'll have some discussion, some opportunity for some Q&A with Jorel here coming up over the next 15 or 20 minutes or so. And also here within a couple of minutes, Kashad is going to post a link in the chat room for a feedback survey. And then also I do want to mention that a week from today, so next Thursday, June 17th, Chris Schmidt from SIMS is going to give us an update on the GOES Fire products in the Satellite Book Club. And also, just want to remind everyone that if you do have any questions For the Towers S team, you can certainly contact Lee Byerly or Kashad Bowman, and they can also help you with getting any of these satellite products into your system if you need any assistance with configuration. So more information to follow from them, and also they have that chat room that is available there. So with that said, let's jump right into some discussion. If anyone has any questions for Jorel, you can either type them into the chat room and we'll go through them, or if you would like to ask a question, you certainly can indicate that you do want to ask a question verbally in the room as well. And so Jorel, I'll get us started here. And a question that I have for you, I think you alluded to on the last slide. Have you heard of any particular secondhand stories or feedback from any of the field offices or forecasters about ways that they've maybe used this, or even some of the incident meteorologists, perhaps if they've had applications of some of the viewers products that they might have used?
Main things, definitely the HERS smoke in regards to any kind of smoke messaging for particular urban corridors or urban areas. I know that one has taken off over the past few years in regards to any kind of smoke forecasting. Some other ones, especially like via social media, I've seen a lot of the nighttime visible imagery here and there, usually just in a snapshot or in a static image or so, highlighting. A good case is, I believe here, actually, if you see on the screen with NWS Pendleton, Oregon, I believe they not only show the fires there, but they also can see some of that fire smoke just off to the west as well. And I know trying to observe fire smoke at night is quite challenging, and I know the nighttime visible imagery can be helpful in that, although of course with the polar orbiting data sets they're not as timely as the GOES. But those two in particular, and then it'll be really interesting to see this year, especially with the Veers Fire RGBs, and seeing what kind of feedback we get on those for the fire temperature and also the dayland cloud fire RGB. Right now, we're trying to bring more exposure to those RGBs to the NWS user community, and also try to get their feedback on those and see what kind of stories we get from that as well.
Yeah, that's a great point. I know myself, my office, we're not as familiar with those particular RGBs. Looking forward to trying them out and using them. And as you mentioned, that nighttime identification of smoke layers is one of the bigger challenges that I think my office has. And even if it's from western wildfires in the timber, the smoke aloft reaching our area often has implications for high temperature forecasts and things like that. And we have a really hard time identifying it at night. So this is a great application of that. And then, of course, as you mentioned, the HERS smoke is very popular in my office as well. The forecasters really like to use it. It gives us another indication of where that smoke may be, even aloft in our part of the area or the world. But even, some of our local fires that, are in heavier fuels and things like that, we do get identifications from the HERS smoke product. And as you mentioned, I'm sure it makes a big difference having this imagery as part of that assimilation scheme.
Yes, indeed. Yes, indeed.
So as I said, if anybody has any other questions, feel free to throw them into the chat. Another question that comes to my mind, Jorel, and just because maybe there's folks out there that are not familiar with it, and I know it's sometimes something we talk about in my office a little bit too. Is there parallax to worry about when we're talking about looking at fires with this imagery or not?
That's a good question. I'm trying to remember on top of my head. I know definitely during because within the satellite swath, definitely during or under the satellite subpoints, shouldn't be any parallax, but I think my only question is the edges. And I don't remember on top of my head of the parallax near the edges, or how, or to what degree. But I'll have to get back to you on that to get the exact details of the parallax, if there is, at the edges of those scans.
No, thank you. Appreciate that. And that makes sense. And I do see a chat from Curtis that says Veers products are parallax corrected. So that's good to know. Good to know. And I feel better that you didn't know the answer to that right off the top of your head either, because I was thinking I should know this. And we talk about stuff like this. So that's fantastic to know. Thank you, Jorel. Thank you, Curtis, for chiming in there. Really appreciate it. Yeah. So another thought that came to my mind as we were sort of talking about all of this stuff, you mentioned that Veers is very sensitive to burn scars as well. And then that kind of led me to wonder, maybe there's an application of this, when we're talking about post-fire analysis. We're talking about post-burn scar, flash flooding, and mudslide risks and things like that. Kind of made me wonder, maybe there's some other applications there that can be really used to help map out some of the areas that are at risk, or maybe even, in a forecast office, maybe that helps immediately get an idea about the region that's at risk before the actual shape files might be developed by the fire agencies and things like that can be imported into AWIPS. I think that's a pretty involved process, but maybe VIIRS is something we can use immediately, perhaps, to identify those regions that are more at risk when we're drawing warning polygons and things like that, for example. I don't know, but maybe you have some thoughts on that. That's just something that came to my mind.
Yeah, it'll be really interesting. Actually, I'll just go back to my slides here. I'll go to the first one, or one of the first few ones here. Sorry, so many animations, so little time. Hold on one second. Let's see here. Oh, sorry. One more. Let's go with the next one. Here you go. So yeah, it will be really interesting, as you were mentioning, Chauncey. Here's a great example, especially in my neck of the woods in north central Colorado, where we have 3 big burn scars. One, the Bowen fire, the Cameron Peak fire, which got really close, really unnervingly close to Fort Collins, along with the East Troublesome fire as well. And we have these burn scars, and it'll be interesting to see in regards to the hydrological applications of what products could be useful for you guys, in addition to the VIIRS RGBs here, in observing to allow the flash flood potential, especially for this year, and any kind of convection that fires over these burn scars. So yeah, it'll be really interesting. This is just one case example. I know there's a lot of burn scars out there across the CONUS, but just in my neck of the woods, it'll be really interesting to see what other products could be utilized as well.
Yeah, I totally agree. I think it's really fascinating. And even though those fires aren't in my particular area, I'm well versed in them. I remember them well occurring, as many of the folks with us on the call probably do, just given their intensity from last year. And I think it's going to be pretty interesting to see the applications. And maybe just like we did with GOES, when GOES R series came along and the field offices are in the field, we had to learn some things about it. And I could see some similar things here too, where we really find out the applications in the coming years. And maybe an unfortunate side effect of having busy fire seasons, which looks to be another busy fire season, but we probably can learn a lot more from it as well.
Yes.
So a couple of comments, it looks like in the chat room. It looks like Sheldon Cusselson did post in there some links for some of the satellite moisture loops and things like that, the advected layer PW that Jorel had kind of mentioned during the slide, some of those products. So go ahead and take a look at the chat if you're interested in some of those links. And it looks like we have a comment from Timothy Dorman that he has family that lives in California. He's wondering if there are links that can provide access to usable information to them when their fires appear in the area, more real time, I think. The detail provided by the media was not enough for their curiosity, and I can attest to knowing how that goes when you have a fire nearby. You even if it's a small one in my part of the world at times, you want to know information about that. So I guess is there places, Jorel, where a person could look, even in the public, to kind of get some idea about using some of these products where some of these fires may be located?
Yeah, actually, I have it here on my slide where I was mentioning some of the resources that we have for users, and they could be applicable for NWS users, but then also non-NOAA users or even the public, because as I mentioned, these links consist of JPSS near real-time data sets for users, and should be useful for you depending on what you're trying to observe, whether it be just looking for the fire hotspots or fire smoke or the burn scar, so on and so forth. But this link here to these documents can also be useful for the public as well, and they should be publicly available for all users.
Excellent. That's great to know. Yeah, thank you, Jorel. Thank you, Timothy, for asking that question. And even thinking from the Field Weather Service perspective, that's maybe the kind of link that we could even share on our social media. Sometimes things like that often get a lot of traction. Folks, some of the more sciencey folks that follow us on social media love that sort of stuff, and even just general public users as well. And so maybe that's something we can use in our social media. And I see that Scott Lindstrom did chime in and say that he recalls
that Google was including fire information in their mappings last year. Doesn't recall the details of the timeliness, but it does kind of make you wonder, where they get some of that information from, and maybe some of their AI efforts and things like that do include some of this data, or could in the future. That's probably some interesting things to kind of think about.
Yeah, that's a good point. I have seen on the Google Maps interfaces, just as Scott mentioned there, I believe they do mention ghost detection, but now to what degree and the details and the timeliness of it, I'm not for sure. But I've seen it this year as well in their Google Map interface. I saw it just earlier this week with some of the fires out there east of Phoenix. I forgot what I think it's called the Telegraph Fire, I believe, and another fire or two out there. And I know there's another fire out there in Utah right now, or there was one within the last 2 or 3 days as well. And I believe that Google interface is still bringing that information to light to the public within its interface.
Yeah, that's fascinating. It's interesting to see, how the private sector really uses some of this data, and it's interesting to hear you mention that they're using the GOES data in there. Maybe they will also use the JPSS data in time if they follow your best practice, which you outlined for all of us here, which is to use them together, right? It seems like that definitely made a big difference. I really liked that example you showed of the two side by side, and really the pros and cons of advantages and disadvantages of both. And I think that's probably a common thing that would be a question that I would get from forecasters in my office, for example, sharing this imagery is, or what, is one better than the other? And as you said, the answer is no, right? It's that we need to use them in tandem together.
Correct.
I see Sheldon also did share a link to the NESDIS hazard mapping, fire and smoke analysis as well. And I guess maybe sort of related to that and sort of along those lines. One other question that I had, and I don't know if you'll know the details of this. This is maybe in the weeds, but you mentioned the fire confidence probability, which kind of interested me. And I was kind of curious if you could share a little bit more, if you know a little bit more about how those probabilities get assigned to that fire confidence product.
Oh, that one, that one is definitely gets into the weeds, and I'll have to defer. I did see Yvonne Cesar on there, one of the product developers, I believe, for the active fire product. So if Yvonne, if you can mention whether that be via the chat or the if you could speak, that'd be speak on that topic, that'd be greatly appreciated. But I know it's a little bit more in detail.
Oh, and I see Yvonne did post in there. It's based on a logic of how strong the signal is. That makes sense. I figured that might be an in the weeds question that is maybe worthy of its own talk, that you're just trying to sell us on this and get us to use it. And I'm asking the hardball questions, but that makes sense. That I was curious. I figured it was probably something related to the signal. So thank you very much for sharing that. That makes sense to me. And it said added how well the various tests perform. That makes sense.
Yeah, thank you, Yvonne, for chiming in. I appreciate it.
Yeah, thank you. Does anybody else have any questions? I certainly don't mean to hog the floor and discuss with Jorel here, although I'm having a good time, and hopefully everyone's is interested in the topics that we're talking about here. But does anybody else have any other questions for Jorel or for the group? Not seeing any, so I'll follow up with just one last question, maybe, Jorel, and then we'll maybe give folks one last chance to ask some. And you mentioned JPSS 2, maybe hopefully scheduled for launch late in 2022, which is not that far away now, I guess. So that's kind of exciting. And I was kind of curious, and again, this is maybe a broader question that's maybe a little bit beyond just your talk, but I don't know much about that. Is that going to sort of replace the existing system, or are we going to get additional passes, or what's sort of the broader scale plan for that, and maybe how it relates to this fire monitoring potentially down the road as well?
Yeah, it'll be interesting because I believe JPSS 2 is tentatively scheduled at the moment, so tentatively scheduled, I believe, September 2022, and we'll see if that sticks to that date or if it gets pushed. But it'll be interesting once that launches and then gets into orbit, goes through the quality checkout, and then we're able to get some of the real-time imagery. But as I mentioned earlier, we have SNPP that's still orbiting the globe and still producing datasets, and that's been out there since 2011, 2012 timeframe. So it'll be interesting if if we'll be able to, as I theorize, potentially 3 satellites up there, or if unfortunately SNPP then stops working for whatever reason, I would surmise that J1 and J2 would be the ones orbiting the globe producing data sets. But I guess it's an open-ended question of how many satellites will be out there once J2 launches and produces near real-time imagery. You know, I could see just J1 and J2, or it could be all 3 SNPP, J1 and J2 producing data sets for users. So, but we'll see. We'll see.
Yeah, no, that makes sense. Makes sense to me. And of course, as a user, I want all the data I can get. That's why I asked that question. You know, I have to ask, oh, can there be more? But
yes, more data. More data, better.
Well, thank you so much, Jorel. I've learned a lot this morning. I really appreciate you sharing all of this. And I won't say that I'm looking forward to fire season, because we don't want to do that, of course, but I do look forward to using these products and learning more about them and experiencing them through the course of this fire season. And so thank you for the presentation. Thank you for the opportunity to help sort of lead the Q&A. And with that, I'm going to turn it back over to Kashad to kind of bring us home and wrap things up.
Thank you,
All
Chauncey.
right, thank you, Chauncey, for leading the discussion today. And thank you, Jorel, for your presentation. We all really enjoyed it. Just a quick reminder, for next week, Thursday, June 17th, we have Chris Schmidt from SIMS, who will give an update on the Ghost Fire products. And also, just another quick reminder to contact Lee Byerly or myself if you have any questions regarding the Satellite Book Club. Thanks, everyone, for attending. Stay well. Bye now.